Okay, we're going to talk about threads and fasteners. Fasteners are nuts and bolts and screws and washers and keys and pins. Fastener is something that is not a permanent means of assembly like welding or adhesives. Screw thread is a ridge of uniform section in the form of a helix. Here's an external thread and an internal thread. External thread, it's cut using a die or a lathe. So we start off with a rod, and then this cuts the thread into that. And internal threads are on the inside of a member, like here. Internal thread is cut using a tap. Okay, on our thread tables there is a tap hole size. That is what size you drill the hole, and then you tap it using one of these. Okay, the definitions, we have the major diameter, and that's the largest diameter. We have the minor diameter, which is the smallest diameter. We have the thread, or the depth of the thread, which is the major diameter minus the minor diameter divided by 2. And we have the pitch diameter, and that's the diameter at which a line cuts the spaces and threads equally. Okay, we have the crest, the root, the side, the pitch, the angle, the screw axis, and the lead. Okay, here is the axis, which is the center line through the member. We have the pitch, which is from one point on the thread to the corresponding point on another. The crest is the very top of the thread. The root is the very bottom. Okay, the minor diameter is the smallest diameter. The major diameter is the largest diameter. The thread depth is the difference between those two divided by 2. The pitch diameter is an equal space between these two. The angle is the angle of the thread, and this is called the side. Okay, so these are some terms you should know. Okay, we have left-handed and right-handed threads. Left-handed threads will advance when they're turned clockwise. Okay, left-handed, of course, advances when it's turned counterclockwise. If it's not specified, it's going to be assumed that it is a right-handed thread. Okay, there's a whole bunch of different thread forms available. The most common are unified and metric. Okay, here is what they look like as a unified screw thread. That is for general use. We have an isometric screw thread. That too is for general use. We have a square thread. Okay, and that's used for power transmission. Here's an Acme thread. It's similar to the square thread except on an angle, so it is stronger. Here we have a buttress designed to handle heavy forces in one direction. If you ever seen an old jack, okay, they had buttress threads on them. Okay, drawing the screw threads. There are 3 different methods we can use. There are detailed, schematic, and simplified. Okay, everything we're looking at is in accordance to the ASME standards. Okay, the first is a detailed representation. A detailed representation is a close approximation to the appearance of an actual screw thread. Okay, here's an external thread and an internal. These are both detailed representations. Okay, the pros and cons. The pros, that it looks good and it clearly represents what a thread looks like. Con is it takes way too long to draw, and there is absolutely positively no reason to draw them. Schematic representation uses staggered lines to represent the thread roots and crests. So we draw the major diameter, okay, and we have our pitch in between each one of those. We have the minor diameter with the chamfer on the front here. Okay, nearly as effective as a detailed representation because you can tell what it is. It is a thread. Okay, and it's much easier to draw. Still takes more time than it should. Okay, a schematic thread should not be used for hidden internal threads or sections of external threads. It'll look like this. These are correct. Simplified representation uses visible and hidden lines to represent the major and minor diameters. Simple as that. Okay, here is a standard view. Here is a section view. You normally do not section screws, but if you did, it would look like that. Okay, this by far is the fastest and easiest to draw. Con is it doesn't look like a thread, but everyone knows that that represents a thread. There shouldn't be any problem with that. Okay, here's how it will look. Okay, here's the top view, side view, bottom view. Okay, and here's a section view. Okay, here are the parts of a simplified internal thread. Okay, thread tables are used to look up the values of our pitch, our major and minor diameter, and tap drill diameter. If you don't have screw thread tables available, the minor diameter is approximately 75% of the major diameter. Okay, unified threads. Okay, after drawing a thread, we need to identify the size and the thread form in a thread note. Okay, here is a typical thread note: 1/2, 13 UNC 2A right hand, RH. That is a thread note. Okay, the first number is the major diameter, then the threads per inch. This is the thread form in series. This is the thread class. This is whether it is an external thread or an internal thread. This is right-handed or left-handed. And then our depth symbol, and then the depth of the thread. Okay, again, the major diameter is the largest diameter. Threads per inch is the number of threads per inch for a particular diameter. Okay, equals to 1 over the pitch. Okay, the thread form in series. Okay, the most common are UNC, Unified National Coarse, for general use, UNF, Unified National Fine, for higher tightness. UNEF is Unified National Extra Fine, okay, like for sheet metal. Okay, the thread class here is the closest of fit between two mating parts. One is a generous tolerance for rapid assembly and disassembly. 2 is normal production. 3 is high accuracy. Okay, we normally, if it is not there, we will assume it is a number 2. Okay, internal or external threads. A is an external thread. B is an internal thread. RH, of course, is right-handed. LH is left-handed. Okay, again, if it's not stated, it is assumed that it is right-handed. Okay, the depth of the thread is given at the end of the note and indicates the thread depth for internal threads. Okay, it's not the tap drill depth. This is the depth to not the point, but the flat on the end of the thread. Okay, thread classes are assumed to be 2. Threads are assumed to be right-handed. Okay, Unified National Thread Note components. Okay, so we have a 1/4 20 UNC 2A RH. The 1/4 is the major diameter. You'll notice that some of them are in the decimal, and then of course we have the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which are a little different. 20 is the threads per inch. The pitch equals 1 over 20, or 0.05. UNC is the thread form and series. This is a UNC, Unified National Course. 2 is the thread class, that's normal. A is an external thread. RH is right-handed. Standard screw tables are available in order to look up all of these different things. I think I said this one already. Okay, the Unified National Thread Node. Okay, here is a thread table. Tells us here the approximate minor diameter is the major diameter minus 1.0825 times the pitch. Okay, so here's, for example, number 10. Okay, that is the nominal size in inches. Again, we go 0 through 10 and then 12. Okay, and then we have the decimal, or I mean the fractional numbers. Okay, so number 10, the major diameter is 0.1900. Okay, UNC is 24 threads per inch. The tap drill is 0.149. A UNF is 32 threads per inch. The tap drill is 159. Okay, so for writing the note for a number 10 fine thread, that is a 10-32 UNF for Unified National Fine. Okay, metric threads. The metric thread, okay, you'll see M means it's a metric form. The next number is the major diameter. This is in millimeters. Okay, this is the pitch. Okay, this here is the tolerance class. Okay, this is the crest tolerance. This is the pitch diameter tolerance. Those you get from the books. We don't figure those out. Here is whether it's left-handed or right-handed. Okay, again, the M means that it's a major diameter, that it's a metric thread. Okay, then of course the pitch. Tolerance class is the looseness or tightness of fits. The number is the tolerance grade, the letter is the tolerance position. Okay, and usually uppercase letters are internal, lowercase letters are external. Okay, there are 2 classes of metric thread fits that are generally used. 6H, 6G is general purpose. 6H, 5G, 6G is a closer fit. Okay, again, the nominal tolerance class is 6H, 6G. It is assumed if that is not specified. Okay, again, the LH or RH for left-handed and right-handed. Depth of the thread, again, is our depth symbol, and then the depth of the thread in millimeters. Okay, again, if this is left off, it is assumed that it's 6H, 6G, and that it's right-handed. Okay, so if we have an M10 by 1.5 for H6H for RH, it is metric. It is 10 millimeters in major diameter. 1.5 is threads, millimeters over threads, it's the pitch. 4H is the pitch diameter tolerance. 6H is the crest tolerance of the major diameter. Okay, this one is an external. Okay, RH is a right-handed thread. Okay, drawing bolts. Okay, D represents the major diameter, that is here. Okay, and a bolt is usually about the same. Here is the distance across the flats. It is usually 1.5 times the major diameter. Here is the height, which is 2/3 diameter, or the diameter depending on how it's made. Okay, we then can draw a 60-degree angle here and here. Okay, and that will be this radius here. We draw another one through this point where they go. Okay, for here and here, and that will be that little one. We will be drawing one of these in a couple minutes, so if you're a little confused on that, don't worry, we're going to draw them. Okay, bolt and screw clearances. Sometimes bolts or screw heads need to be flush with the surface. This can be achieved using either a counterbore or a countersink depending on the fastener. Okay, if we have something like this, like a cap screw, okay, we're going to use a counterbore. We have something like this, a flathead screw, we'll be using a countersink. Okay, counter bores are holes designed to recess bolt or screw heads below the surface of the part. Okay, here is the diameter of the head. Here is the diameter of the screw itself, or the bolt itself. Okay, the height of, or the depth of the counterbore is the height plus a 1/16. Okay, the diameter of the bigger hole is usually diameter plus an 1/8. Countersink are angled holes that are designed to recess screws with angled heads. Okay, again, typically this outer portion here, okay, is the diameter here plus an 1/8. Okay, here's a dimension of a hex and spline socket head cap screw. Okay, so here's the screw size, here's the head diameter. Again, you can see from 1/4 to 4 inches, the head size is 1.5 times the diameter. The head height, the max, is the height of the diameter. Okay, and here are for 0 through 10 the different head diameter sizes. Okay, here are standard counter bores and counter sinks. Okay, so here is, for example, if I had a 5/16 18 UNC socket head cap screw. Okay, using those charts, these would be the maximum head diameter would be 0.469. Head height would be 5/16. Notice the same as the major diameter. Clearance hole would be 11/32. The counterbore would be 17/32, and the depth would be about 3/8. Okay, standard parts are parts that are purchased. We don't need to draw them. Okay, we just use a standard part sheet. Okay, so here you'll see there's a find number where it is. This is how many there are. Here is a part number, a part name. Here is the size, any series and material. So here you see we have a compression spring, a washer, a hex head cap screw, and a spring pin. We wouldn't draw any of those because these are purchased this way. Okay, that is it for the talking portion of the threads. Okay, now we're going to draw some threads, and we'll draw all 3 types, and we'll draw a bolt, and we'll see how it goes from there. Okay, we are going to draw some of the threads that we looked at. We're going to draw a detail thread, a schematic thread, and a simplified thread. Okay, these are all showing the same size threads. Okay, so we're going to create a 1024 UNC 2A 750 thousandths long. We need to find the major diameter, the pitch, the minor diameter. Okay, and we don't really need the tap drill, but we could find it anyway. So here's our chart. Here's a number 10. Our major diameter is 190. It is a UNC, so that is 24 threads per inch. Okay, here's the tap drill if we needed it. Okay, to find the minor diameter. Okay, it is the major diameter minus 1.0825 times the pitch, or 0.144. The thread depth is 0.022. Okay, our pitch is 1 divided by 0.024 or 0.042. Okay, so we're going to go into AutoCAD and we're going to start drawing threads. And what I'm going to do first is I'm going to make the outline of our bolt. So I'll start here with a line and I'll go down. I'm going to put F8 on and I'll go down 190. Now I'll go over 0.750 and then I'll finish up that rectangle. Okay, we're going to draw all three. Okay, the detailed, simplified, and schematic. So I'm going to copy this two more times so I have three here. I'll put one there and there. Okay, I'm going to zoom up on this guy. This is going to be our detail thread. Okay, to start off, I'm going to draw a construction line from here to here and from here to here. Now I'm going to offset this half of the pitch and I'm going to offset this a pitch. That way that the crest of the threads are shifted a little bit. Okay, so I'm going to offset, and our pitch is 0.42, so I'm going to go 0.21 from here to here, and then I'm going to offset this bottom one, 0.042, from there to there, and I will offset this one from here to here, 0.42. Okay, I'm going to go in and I'm going to set my polar snap to 30-60. I'm going to draw a 60-degree line, so I'm going to go up here to line. Okay, and right where this intersection is, I'm going to come down and I'm going to take my F8 off and I'm going to go down 60. I'm going to put my polar on, make sure it's on. Okay, so I'm going to go down 60. Okay, I'm going to go down 60 here. Okay, and I'm going to go down 60 here, and then here, and here. Okay, I'm going to trim those guys off a little bit. These two, and these two. I don't need these lines or these lines. Okay, now what I'm going to do is array this 18 times. So first I'm going to draw my lines, and I have a line from here to here, and then a line from here to here. Okay, and that should be enough. That should be all I need. Okay, I actually don't need this line here. Okay, so I have this. I'm going to take it, I'm going to do a rectangular array. Pick all these lines. I'm going to unpick this line because I really don't want this one. Okay, I'm going to hit OK. I'm going to have 18 columns for my 18 threads. The distance between them is going to be 0.042. The number of rows is going to be 1, and actually I'm going to make this negative 0.014 if you know 042 if you notice it's going the wrong way. I'm going to go minus 0.042. Okay, and I'm going to close the array. Okay, so now I have my thread here. Okay, now I have my threads, and I'm going to put a chamfer on the leading edge here. So I'm going to set my polar to 45 degrees. Okay, I'm going to draw a line from the trough straight across, and from this trough straight across here. Okay, and I'm going to draw my 45-degree line from this intersection, then I'll back 45, and then from this one here I'm going to go and I'll draw the trough 45 this way. Okay, now I need to trim these guys away, so I will trim this one, okay, that one, and that one. Okay, this line here will be gone, this line here will be gone, this line here will be gone. Okay, trim this guy up here, trim him there, and there, and there, and then I'll delete these guys, and I'll draw a new line from this intersection to that intersection there. Okay, so there's the front of my thread. I can delete this line, and maybe I shouldn't have, but I will. Okay, I'm going to take this line now. I'm going to draw part of the shaft. I'm going to draw it as a break. So I'm going to offset, okay, from here about 2 threads or a little bit less. So I'm going to make that 0.070 from here to here. Then I'm going to offset 0.35, and that's just a number I came up with just because I know it's going to look good. You have to play around with them and find out what your number should be. I'm going to draw a line from the midpoint here to the midpoint here. Okay, now I'm going to offset. Okay, I'm going to draw a line from here to there, from there to there. Okay, now I'm going to offset this line here, and that is about 0.050 from here to here, and 50 from here to here. Okay, now I'm going to use my spline. Okay, so I'm going to go to draw, and I'm going to go to the first spline here, and I'm going to draw from this intersection. Okay, whoops, I'm going to draw from this intersection, intersect to that intersection, okay, to that intersection. Okay, then I'm going to draw from this intersection there to there. Okay, so that's my break that I have here. Okay, I'm going to trim these guys off here. Okay, I'm also going to trim this guy right here. I'm going to come to here. I'm going to trim this guy here and here. Oops. Trim him there and there. Okay, I'm going to delete this one here. And I'm going to draw a line from here to here. Delete these lines. Oops. This one, that one. I accidentally deleted my spline here. I'll put this one back here, here, and here. Here, here, and here. Alright, now I want to delete this line, this line, this one, and these two. Okay, so there is my detailed. Okay, now I'm going to draw the schematic. Okay, so what I'm going to do is I'm going to offset here and here, and here and here, half of the pitch. Okay, and then half of the pitch up top, and the whole pitch down the bottom. Okay, so I'm going to zoom up here a little bit, and I'm going to offset 0.021 here. I'm going to offset 0.042 here. I'm going to offset 0.021 here and here. Okay, I'm going to make a chamfer. Okay, and the distance is going to be half of our pitch, 0.21. Okay, and distance 2, 0.21, I'm going to take it from here to here, and here to here. Okay, I'm going to offset here 0.021. Okay, I'm going to trim this line right here. Okay, I don't need that line, and I'm going to delete these two. Okay, now I can make my array of those, so I'm going to make a rectangular array, and I just need these two lines. Okay, again I'm going to have 18, negative 0.042, and one row. Okay, and I'm going to pick close. Okay, now I have my last row here. Okay, let's get rid of that guy. Okay, I can now take, if I like, and I can take this one here, and we'll copy it from here to here. Oops, I moved it. So why don't we try copy from here to here. Okay, now we're going to make our simplified, and I will offset 0.021 again from here to here and here to here. I will make a chamfer. Distance is going to be 0.21 in both ways. I'm going to chamfer here and here, here and here. I'm going to change these two lines to hidden. Okay, I'm going to change the properties a little bit, make them a little smaller so it looks better. I'll change this line type scale to 0.5. That looks good. Okay, and then I will take and copy this one from here to here. I copied those lines, but I don't need them. Okay, so those are all three of our threads. Okay, now we're going to draw our hex head and our nut. Okay, so here are the dimensions we will use. Okay, across the flat will be 1/2 of the major diameter. Here is the major diameter. Okay, the thickness is going to be 2/3 the diameter. Okay, and we're going to create a 60-degree angle here. Okay, that's going to give us this radius right here. Okay, then we're going to create a radius here and here, and then we have a 30-degree chamfer there. Okay, so the D, our major diameter, is 190. The thickness is 2/3 times that diameter, which is 0.126. The distance between the flats is 1.5 times the diameter, minus, or is 1.5 times 0.190, which is 285. Alright, so we're going to go back into our AutoCAD drawing, and I've gone into the detail one and I've deleted the break here. Okay, so we're going to leave some space here. Usually the nut has, or the screw has some space left over. Okay, and I'm going to make that 0.375, so I'm going to offset 0.375 from here to here. Okay, I'm also going to create now our hex head. Okay, I'm going to put it on this side over here. So I'm going to go into circle, center, and diameter. Okay, and I'm going to make it in the center here. Okay, at the midpoint, and drag it all the way over here, and I'm going to put it maybe about here. Okay, and then that diameter is going to be 0.285. Okay, now we're going to draw our hexagon inscribed inside of that. Okay, so I'm going to go up to hexagon or polygon, six-sided. Here is the center. Okay, it's going to be circumscribed, which means the flats are going to be right here. Okay, so we're going to use this for our head height. Okay, so I'm going to take and I'm going to draw a line here to here, and then a line from here to here. Finish that one up. Okay. All right. Now probably be a better idea if I just took and I extended this one, so we have one whole line there. Okay, and I'm going to put a fillet here to trim those up. All right, so that should be the unthreaded portion. Now I'm going to draw our head in there, so I'm going to go from the points. Okay, so I'm going to go from this end point, I'm going to line up with this end point. Okay, I'm going to go here, and the thickness was 0.124. Okay, and I'm going to come down to this guy right there, and I'm going to come over to this one, and then I'll complete that line up to there. I'm going to draw a line where these are. I'm going to go here, that end point, here to here, and then from here to there. Okay, now I'm going to draw two lines here from this edge here, or from this intersection here. So I'm going to make sure that my polar tracking is on 3060. And I'm going to draw a line, and I'm going to draw it from this corner right here. And I'm going to go down 30 degrees. Okay, and I'm going to draw another one from here, and I'm going to go 30 degrees. Okay, now I'm going to draw an arc, the radius from this section to here. So I'm going to go to circle, center, and radius, and I'm going to draw it from this intersection to this midpoint. Okay, I'm now going to trim it off at those two lines. Excuse me. Right there. Okay. Now what I'm going to do is I'm going to draw a three-point arc from this point to the midpoint of this line here. Okay, lining up with this point here. Okay, I'm going to delete this line because I really don't need it. Alright, so I'm going to go on a three-point arc, and I'm going to pick this endpoint. Now I need to pick the endpoint between, or the midpoint between these two endpoints. If you hold your shift button and right click, you'll see mid between 2 points. I'm going to pick that, and I want between this endpoint and this endpoint. Okay, then I'm going to come and I'm going to make it even with this endpoint. Okay, and there is my arc. Okay, I'm going to take and I'm going to mirror that. Easiest way to do it. And I'm going to go from the midpoint here to the midpoint there, and I'm not going to delete it. Okay, and then I don't need this line. Okay, I need to draw a 30-degree angle here. So I'm going to go to this intersection and I'm going to draw that 30 degrees. Okay, and I'll draw the same thing down here. Here, 30 degrees. Okay, let's trim some of this guy up. Okay, I'll trim this one here and here, 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 and here. Okay, now also on the bottom of these, we do have a little washer, okay, that's built into it, and that is the diameter of this hole here, and it's about 10 thousandths. So I'm going to draw a line from this quadrant to here, and I'm going to go 0.01, and I'll go down to this quadrant here, straight across to that one, over to there, and then I will trim this guy up here and here. Okay, so there is my hex head. Now we can take that head and we can use it to create a nut. The nut's going to be exactly the same, except it's going to be this side mirrored over to this side. Okay, so what I'm going to do is I'm going to copy this over here to make the nut. So I'll go to copy and I'll grab everything right here. I don't need that little washer. Okay, and I'll drag it, put my F8 on, and I'll drag it over here. Okay. I'll then zoom up on this guy, and what I'm going to do is I'm going to draw a line, make sure I get the center point right here. Okay, and then I'm going to delete this line here and here, and I'm going to mirror this. I'm going to mirror, grab these guys. I'll go from the midpoint of this line that we drew straight down. Okay, and no, I don't want to delete that. And then I can trim this guy up here, here, and here. Okay, now I have my screw and my nut. Okay, if I want, I could take and move this guy over. Put him on the screw. Maybe like that there. Okay, now I need to come and I need to trim a lot of this stuff away, so I'm going to trim between this line and that line. Okay, I should be able to trim parts of the screw away, or the threads away. And here. Anything there. Okay. I can delete these guys. Trim this one. That one and that one. Will be gone. That one there is gone. That one there is gone. Okay. I Should be able to delete these now. Okay, and there we have our hex head, the top, and our nut on the bolt. Okay, that is it for this part of the lesson. Okay, the last thing we're going to look at here is we're going to look at drawing an internal thread. Okay, you'll notice it is an internal simplified thread. That is how we normally draw internal threads. Okay, we never draw them as detailed threads, and we seldom draw them as schematic. Okay, mainly because they'll just look like a mess. Okay, so we're going to draw it like this. Okay, and we need the major diameter, the minor diameter. Okay, here is our thread length. The one that we did was 0.75. Then we leave 3 times the pitch. Okay, that's not threaded. And then we put an angle here, and that's going to be the angle of our drill point. Okay, we usually put about 30 degrees there. Okay, we're going to draw hidden right here. This is the hidden views, and then this is a section view of the same thing. So we're going to do both of those. Okay, so we're going to go into AutoCAD and we're going to take a look at that. Back to AutoCAD, and I'm looking at our simplified thread that we drew. I drew a box here 1 by 3/4, and I centered it up with this guy here. Okay, the first thing I'm going to do is I'm going to put in our depth of our thread. So I'm going to offset that, and that is 0.75. Okay, I'm then going to offset 3 times our pitch. Our pitch is 0.042. That comes out to 0.126. Okay, I'm now going to make sure that I'm in the hidden layer, and I'm going to draw a line starting at our major diameter. Okay, and our major diameter is going to come down to where our thread length is. And I'll draw one on this side as well. Okay, we're going to draw our minor diameter, and that's going to go all the way down to here. Okay, I'm going to offset here because I need to put a chamfer there, so I'm going to offset half the pitch, which is 0.021. And I'll draw a line from here to here. This is my chamfer, and from here to here. Okay, while I'm here, let's trim some of that away. I'll trim this guy here. Whoops. This one, these guys here, and that one there. Okay, I'm going to come over here, and I'm going to put our 30-degree angle there. So I'm going to make sure that my polar tracking is on 30, and that it is on. Okay, and then I'm going to draw a 30-degree angle here, which is actually the 60 degrees, and 60 degrees here. Okay, and I'll trim them up with each other. There and there. Okay, and I'll trim this guy and this guy and that one in here. Okay, I'll then take and I'll put these guys on the hidden layer. Make sure they're all on the hidden layer. Okay, and I'm going to take all those hidden lines. I'm going to go to properties. I'm going to make them a little closer together. I'm going to make the line type scale 0.5. Okay, so it looks a little better. Okay, so there is our hidden part of our thread. We actually have one more line to draw on there. Okay, this line is usually kept off, but it should be there, especially if we're doing something small. You can make a hidden line going from there to there. Oops, and from there to there. Okay, now I'm going to take a look at a section of this. So I'm going to copy the whole thing. And I'll just copy it straight across here, right to there. Okay, so now what a section is we're going to take and we're going to cut that piece in half so that this will show as a real line. Okay, so the first thing I'm going to do is I'm going to change my current layer to object. Okay, I'm going to take these lines here, this one here, 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 this one here, 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 and here. Oops, I'm not going to take those two. I'm going to take this one away and that one. Okay, so I'm going to take these lines right here plus this one, and I'm going to put them on the object layer. Okay, now I'm going to hatch this, but I want the hatch to go through the hidden lines. If I hatch it, it would stop at those hidden lines. So I'm going to go up here and I'm going to turn off the hidden layer for a minute. Okay, right here. So I'll turn off the hidden layer so I'll only have the object showing. Okay, then under draw I'm going to go up here to hatch. Okay, and here is the type of hatch we want. It's an ANSI 31. Those are just parallel lines. I'm going to pick on that. Now I just pick an internal spot. Now depending on what we have here, if this was set to 1 for example, which might be default on yours, okay, that's alright, ignore that. Okay, and I click there. Okay, and that might be alright, but I might want to make it a little smaller, so I'll put 0.5. Okay, and that looks better. So now I have my hatch. Now what I'll do is I'll come back in and I'll turn on my hidden layers. Okay, and I'm going to take and I'm going to put this line and this line back on the object lines. Okay, so there I have my section view of my internal thread. Okay, that was a very long lecture about fasteners. Okay, and that is it for now.